It's not a snapshot, it's fully tracing. So you have every operation and you have every call. And normally people say, yeah, but that gets really slow. But we just figured out a way of making this really quick.
In this episode, we sit down with Tyrone from CodeGlass, who shares his inspiring journey from an inquisitive 11-year-old fascinated by computer games to founding a company that aims to revolutionize how developers troubleshoot and optimize code. We discuss the unique features of CodeGlass, which include real-time profiling across multiple programming languages without needing changes to your source code. Tyrone delves into the technical challenges and breakthroughs achieved by his company, such as achieving 10 million operations per second and accurate memory profiling. He also shares insights into his entrepreneurial journey, the challenges of gaining trust in a tool, and the support he received from the academic and startup ecosystem. The Inspiring Computing podcast is where computing meets the real world. This podcast aims to trigger your curiosity by talking to proficient and advanced users of MATLAB, Python, and Julia, who use these tools to deepen their understanding of the world, simulate, explore trade-offs, and gain insights that help companies add more value. In addition to this, we will also be talking to product marketing, toolbox authors, package developers, and library maintainers to see what drives the development and what issues they're solving for others to benefit from. Welcome, Tyrone, to Inspiring Computing.
We are glad to be here. Thank you for inviting me.
Yeah, so you and I, we met at this technical meetup in a beer brewery in the Eindhoven region, and it took me all of 2 nanoseconds to realize that you are a super cool and interesting person based on your company and also based on the questions you were asking in this technical meetup. But before we get into the coolness of your company, do you want to share a few stories of who you are and how did you actually get into programming in the first place? And how did you even start your own company?
I started on really early on, like primary school. The whole class was playing this web-based game, and I just want to know, how does this work? How do you make this? And I started Googling on it, and I found out that you could host one yourself. So after a lot of trial and error, I got it to work. And then I started just digging through the files, figuring out what made that game tick. This way I learned about databases and scripting and JavaScript and all kind of languages to there make it work, and even started to really understand what was happening there. So I still remember I opened a few files and it didn't really make much sense to me at the time, but I quickly figured out that, oh, it were the mapping files of the maps. And if you added, it were all kinds of numbers. And I figured out, oh, if you change it to a 1, you could sit on things. It was marked then as a seat, and then you can sit on that seat, and I could walk through walls. Then that's why I started editing the game, making new assets, even found out, I still know I was such a noob back then, that, hey, how do I make transparent pixels? I can do that in Paint. Paint doesn't have this. How do we do this? I had a lot of fun with that, and that made me already work in the field before I even started studying software engineering.
But hold on, Tara. How old were you at this stage?
I was 11.
Okay.
I think 12. I don't know, something like that. Yeah. And yeah, I had a lot of fun with that and learned a lot about how all these works, and I hosted all kinds of games.
But may I ask, did you have a friend in your circle at the age of 11 which was competing with you, or a friend at school, or was this just pure curiosity, inner drive?
Yeah, pure curiosity. It also helped, or just how you looked at it. I lived very remote. At school, I had a couple of friends, but when I was at home, I was really on my own. So that's automatically made me spend a lot of time behind the PC. And yeah, you're just going to figure out stuff.
Okay, so then you first discovered computers and technology with this game. What was this game called? Do you remember?
It's been a couple of games. The first game was Habbo Hotel. After that was RuneScape.
Okay.
Maple Story.
Ah, yes.
It's a 2D game. I made a lot of assets for that game. It was fun. Wrote the entire start of the game to make it more fun, because you only play custom servers when you're already experienced. So you don't want to go to the hassle of the start again every time. So I rewrote a little story, read thousands of NPC scripting files to figure out, okay, how am I going to script my NPC?
But okay, so you discovered your passion for computing and
Yeah.
technology through computer games, and then did you then decide to go and study computer science or?
Yeah, it was a logical step. Oh, I like programming. I like making stuff with writing codes. Let's do a computer science degree because then I can write the code every day, the whole day, and make my money with it. And funny enough, that also walks into why I started my company. Because yeah, and then I really want to go into that already.
Sure. Tell me a little bit about your company. What's it called, and what do you guys actually do?
My company is called CodeGlass, and what we are doing is solving a lot of problems we have as a developer that prevents us to write a lot of code every day. So a lot of the time is spent on debugging, learning code, explaining code to others, performance issues, helping customers, and etc. It all prevents us from what I at least like to do most. That's something I learned quickly because I started working even before I got my computer science degree. So when I had to do my thesis, I was asked, hey, could I not make something that would help developers? And at that point, I was troubleshooting a really annoying application that kept on crashing when the debugger wasn't attached. You couldn't reproduce it somehow when the debugger was attached, or at least it seemed so. And I hated it. And it was every day something like that. I was more time troubleshooting someone else's fault, actually writing code.
But can you tell me a little bit more about that application?
That specific application was a .NET application. But yeah, I quickly figured that, oh, this is probably going to be my job when I finish my computer science degree is not really write code. This always working in someone else's code, making it work, troubleshooting most of my time. And I really didn't like that.
Hmm.
So I started to think of ways around it. And hey, can I not make this better for myself? And that started out thinking, hey, how could I just see what the code is doing without having the debugger attached? Can I not just look into the running application, see the real time call stack? Then it just explains to me what it is actually doing. And then I can just find the code myself without having to put breakpoints everywhere, finding the entry points, stepping through everything. I started Googling on that because if I have this ID, this must exist already.
Yeah.
There are no new IDs. Everything has already been figured out. At least I thought so. And then I found it didn't exist. I started asking around, and only people had reasons why it shouldn't exist. I couldn't really find a single reason why, common consensus why it didn't exist. So at my thesis, I thought, let's make this. Let's just start building it, and then I will quickly find out why this isn't possible.
So when you say making it during your thesis, let me see if I understand correctly. So is this the idea
Yeah.
that someone gave you some code and you didn't want to read through the thousands of lines of code to understand what was going on?
No.
You didn't want to have to attach a debugger to it to step through it to understand the code paths. You wanted it in an automatic way without a debugger to be able to
No.
parse the execution of a .NET program. And from that
Yeah.
parsing that you get insight of how the program works and the call stacks and all of that. Is that what you're looking for?
Hopefully without the debugger, because that's just easier, then I could run it whenever. But yeah, that's all of it.
This was only for .NET applications only?
For that time, I started working on .NET only. Currently, so the solution that we made is actually working, and you can do this. And we made it for .NET, JavaScript. We have working prototypes for Julia, Rust, Python, C++, Java, and etc. In the end, we made a platform that we can just attach other programs to, other programming languages to, and it works.
So hold on, this is super interesting. So are you telling me that almost independently of the language, you can look at any executable and understand what the call stack is? Or should I think of it just as a call stack? Or are you also looking at other elements than function A calling function B? Or do you also tag how long it takes or how much memory it takes?
Yeah.
Tell me more about this.
So we really started a kind of origin story from where it started. But yeah, at first you could only look into what it was doing, any independent language that we added. But now I quickly figured out that if I can see what applications are doing, I can also measure it and have a really accurate profiler that almost gives you line by line performance statistics without having access or even changes to the source code.
CodeGlass was born? Was it when that realized, oh, I'm going to now create a company? Did the company appear before that?
No, this was around year 4 that I was developing it. It started working, and I really didn't understand why people kept on saying it wasn't possible if it worked on my PC. So I thought am probably doing something wrong, or it probably works only on my machine, or it just works for me. And the first thing I thought of, oh, maybe it only works for the .NET applications. So okay, let's add another language. Which one is the most different that I could think of? And that was JavaScript.
Okay.
Because it's a scripting language, it doesn't have types, it didn't really have classes yet. It's something really different. So I started working on that, and it also worked. At that point in time, a company I was doing a part-time job had a problem and knew I was making this and just asked, hey, Tyrone, can we try it out? Because we have been spending 36 hours on this problem. We don't know what's happening. The customer is mad. Can we just try it? And I said, sure, you have it. Let me know when you installed it, then I will help you through the program. And I think that after 45 minutes, I messaged him, hey, have you installed it yet? And he replied, yeah, we already fixed it. Thank you very much. And then at that point, I thought, okay, wait. So I instantly got validation.
Yeah.
It actually delivers a lot of value. It instantly became true. And at that point, I thought, it is a shame to keep this for myself. I want to help also the other developers in the world. So let's put it online, and then it just works out, right? That doesn't work. There's a lot more in having a startup. Just put it online and people will come. And there my entrepreneurial journey began at the start of 2022.
Okay. So before we go too much down your entrepreneurial
Yeah.
journey, because I'm interested in that, I would like to double click on a few things that you've mentioned. You mentioned the word platform, and you said it's for any language. Walk me through how this works. Does this mean that if I create a program, do I need to execute my program through your program? How does this work?
So we integrated that programming language. You just install CodeGlass and tell CodeGlass, hey, I want to look into this application or this executable or this DLL or this file. And then it just works. You don't have to do anything more. I can run it on Microsoft application. I can run it on the Google website. I can run it on Bash. It just works.
But what do you actually give? Do you just get the
No.
executable itself?
Install CodeGlass locally on your machine.
Okay.
It runs fully locally on your machine, so you don't have to be worried that I do something with your data. No, it just runs locally. So you can run it offline, and you get the data your own. And for example, if you want to profile or look into a remote application, you can do that. It can work over the internet, but it's something you must set up. You must say, open up a few ports, probably put some kind of security on there, etc. And then you can also look into an application on the other side of the world.
So the use case is not just me locally. It could also be for microservices and things like that you log on. But let's zoom into maybe on the locally, because I think that's what most people understand and live and breathe. So let's say I've got a Python project or a .NET project. I compile it or I run it, and then I say to CodeGlass, say, please look at this Python or this executable or this DLL. Do I have a list of drop downs? And once I check a tick box, what do I then see? What's happening a bit behind the scenes? Can you walk me through this a little bit more?
So let's take Python. You select your Python file and you say, okay, I want to look into this Python program. And then either you start it or CodeGlass starts it for you. And then you see everything that application does. Every step it takes, every function it makes in order. So you can step your call stack and play it back and record it, save it to play back later. You can look into the statistics. You can even look into the memory of a specific function, how much memory it uses and which kind of objects it allocates. And if you figure out that there is this memory object that's being allocated a lot of the time, you can also see you use a lot of strings in your application. where the one place that is allocating a gigabyte of memory. Normally, we had to figure that out ourselves, look reference strings and see
Yeah.
who allocated this. Now you can see these are the functions that allocate it. You can even see if it is being deallocated. So you easily can find out which function is leaking memory.
So this seems like too good to be true, right? Because historically, or the way I was brought up, is be that for embedded devices or even technical computing on my laptop, you always need a profiler, and a profiler by definition always injected more code to profile things. So think of it as a little timing here and there, and they're cool tricks to do it automatically, but ultimately you are changing your source code so that you can have hooks or entries to measure specific things. Typically people go through that for either speed, time, or even memory consumption. But the fact always is you were artificially changing your code without breaking its numerical performance, but it was adding more lines of code, so your execution time was not honored 100%, and that was always like a best case scenario. So you would add tools on top of this. So how do you do that without changing the source code or injecting things on it? Or is this like your
Yeah.
secret recipe, or is it OS
No,
dependent?
I can talk a little bit about it on an abstract level. We still inject code in the application. We do it only on the translation layer between languages. So almost any language has an intermediate representation.
Hmm.
Either it is from .NET application, it's Microsoft Intermediate Language. You have the GVM for Java,
EPSEC
and
synthesis tree for Python.
everyone, and only when you execute the application, translates to actual machine instructions. And we figure out in every language that point, and we go in that translation and add our own instructions to it without the developer needing to do that. And that's how we do it without source code access. We can look into applications. And then for the timing, we remove our own overhead from the statistics in such a way that if I remove any more time, we would go back in time. A tick
Yeah.
is the lowest form of time measurement you can have on your machine. On most common, it's 10,000th of a millisecond, but
Yeah.
it's dependent if you have Hyper-V, for example,
Mm.
enabled. Else, your tick frequency can change every time you start your machine. And so we have a way to calculate our own overhead. And if we even remove one more tick from that, you would sometimes get this function started later than it finished.
Yeah. Yeah.
So we're pretty sure that our overhead is removed almost completely, at least to the level of tens, thousands of, and that's how you get really accurate results.
So let me see if I get this straight. So common workflow, let's say Python.NET, is you run your application and it works or not. And typically people put printfs or whatnot to figure out stuff, but that's not the right way. And then some people say good test cases, but even if you have a good test case, you always end up, if something's not working, you put a breakpoint and you step through it. And you're saying, well, hold on, there's another way, or another way of doing it is independently of the user injecting code or breakpoints. When you run an application, if you can understand the language, and when you say supporting the language, that means your CodeGlass software can understand the intermediate representation, you have a means of dissecting that and knowing when functions get called. So you put your own little calls, and you also know exactly how long your overhead is. So when you inject your overhead, you are always sure to remove it. So you give a very accurate execution profile. And because you can do this, you can also record it. And by recording it, you allow people to run something once and debug it as many times without always redoing it at a super speed. So you're effectively empowering developers to analyze specific situations at a much quicker and faster pace without having to add additional tools left and center. Is that the philosophy?
Yeah, exactly. And with current version, we can do 10 million operations per second.
Uh,
We also have a really advanced way of filtering out which operations you don't want to see. For example, the native Python stuff.
yeah.
You don't want to see it. You only want to see your
Uh,
code. And you can very easily, with a few clicks, set it only on code, and then you don't notice it anymore. You don't feel it. Without knowing, you do a lot of stuff. A simple math operation is calling native operations,
Yeah.
but you are not interested in that. Perhaps you are, but then you turn that on, or you say only public functions and private, and you say only the public functions from the system namespace, please, because those are the functions I am able to call. And you can also see the overhead of those system operations, making this very easy. It is so much quicker to troubleshoot. And my problem with existing profilers, why I made my own, was just they were really clunky. There you had to record, or you had to inject code yourself, and you had to record things. It was either sampling or really slow, and then you hoped you had, after the recording, you had the information you need, but most of the time you didn't, or you had too much information that is workable because, for example, you have to turn it on at the start of the application, and then you have a lot of data from the startup, and then you do your operation and you really want the profile, but you have a lot, and
Yeah.
with CodeGlass, you can just, I want to record this execution of this function. Okay, click, and then it gives you the timings of only that operation. You get only the memory of that operation. And instead of, you allocate a lot of strings. Good luck.
Yeah.
You have 40,000 references to string. Good luck.
Yes.
It's finding the line of code instantly what that's misbehaving.
So I recognize this very much that I was even with Python or Julia, whatnot. Simply executing Python, there's a huge overhead. When you look at the profiler results and you look at flame graphs, or be that MATLAB as well as .NET, there's a gazillion things in there that actually I didn't even know. So it's the inner operations of the language, and it feels okay, this is all necessary but noise. And then if I want to zoom into it, you tend to say it's what the code that I wrote or I'm responsible. That's what you care about. And sometimes you see these flame graphs or these stack graphs, which are tremendously long, and it's okay, where do I start? And that becomes an issue. So you're saying that with this, your methodology is you can actually just specify what you're looking into. And then as an end user, that actually makes a lot more sense, right? You just want to see the code. That is super cool. But
and then it brings the issue back to your line of code. It's not even, this function is slow. Good luck with it. No, it's, we know it's in this function on almost this line, or we currently say it's between these function calls is really your bottleneck. Or we show in production, this iterator is executed 100,000 times. That's the problem here. Because without the source code, just looking at what the application is doing, we can reconstruct what your function looks like, your function body. Yeah, because just, function 0 started, it called A, then it called B, then it called C. And then it starts A again, then B, then C. This function is probably a loop that is A, B, and C, and iterated so many times. Every function call is allocated this much memory, and between A and B is so much time. And if there's, for example, the longest time, you can just put your real code to side by side of it, and then we do this. We have a locking statement, or etc. Or a really expensive math operation. That makes sense.
I see. There's another part here which you're saying is you do something additional. So
a lot of
one thing is when you inject yourself into the intermediate representation, whichever layer that is, probably close to execution. But then for the end user, you want to reconstruct it so that he or she identify in their own code, right? Because you never actually saw the source code. So you take that intermediate representation, you rebuild it in probable or common coding formats that then people can recognize, say, I see what's actually happening here.
Yeah, we format it back into the language that the user specified it was. So for C#, we visualize it as a C# application, and for JavaScript. And most of the languages are mostly the same. It's some syntax. One uses a semicolon at the end, others don't. An iteration statement is a for loop or while. Most languages are, in the end, mostly the same.
Yeah, so this kind of makes sense. Now, the engineer in me says this kind of level does not depend on operating systems. So are you bound towards Windows versus Linux and the different variations, or are you at a higher level that you don't care about the OS itself?
Depends mostly on the CPU architecture. not really if it's Linux or Mac or Windows. For example, the implementation already works on Linux, Mac, and Windows, but most work goes into the different kind of CPU architectures, x86, 64, ARM, but the most work goes into that.
Oh, I see.
Yeah.
But then so if I understand, you like you said, are you taking snapshots, or is this a way of thinking at a per second you're taking a snapshot of every execution moment? And does that mean that you're missing things because you're taking snapshots, or is a snapshot a very naive way of thinking about this?
It's not a snapshot, it's fully tracing. So you have every operation and you have every call. And normally people say, yeah, but that gets really slow. But we just figured out a way of making this really quick, and we can also go into how we made that work. So we've been really talking product wise. I would also don't mind to go more to explain how we did things, and that's also why it is possible for us to make that reconstruction, to really see every step your application take, to see how many iterations, where memory is allocated in your application, because we just know, hey, this thread is here in the application, and then we get, hey, there is a new int allocated. Okay, then that thread is currently there. So this function must allocate that integer. And then we keep track of the memory address for at least most languages, depends on how manage their memory. And then we just look at, for example, a garbage collection is run. When it deallocates that memory, we know, oh, that function that allocated this memory now has its memory deallocated. And that way, if a function is leaking memory, or for example, it just has a caching issue, you only cache but never clear your cache. Oh, it's over there because he only allocates, and what he allocates is never deallocated. So, and that's why this system works for C and C++, where you must specifically deallocate.
Yeah.
It works, but also for the .NET applications or Julia that has a garbage collector.
Okay. So there's a couple of things here. So you keep saying things like this is super easy, but okay. There's more to this than meets the eye. So this is, to be clear, snapshotting. It's not.
It's straight.
Is this because that's the processing power that you need to be able to run your program? Is that the limiting factor?
Oh, yeah, I should state that better. So after 10 million operations per second, your application that you are, let's call it profiling, slows down because we can't keep up. This is because it is actually analyzing and processing this data in real time. If it's when your bottleneck is starting to show up there, and then your application throttles. And we actually also made features out of this, so you can specifically throttle applications just to, for example, if you want to see, hey, how does this application work? Just say, let's execute at 10 functions per second and just look at how this login sequence works. And we can also pause applications and then step through the applications, a step back, not really in time. We just looked in the history.
Oh, I see. So the way should I think about it is that number that you mentioned of limiting, that probably depends also on architecture, CPU, processing power, but it effectively means there's an upper limit of your throughput. Most applications themselves, they don't max out CPU performance too much. And if you've got multiple cores or something, I'm assuming you can do something special there if you notice something's available. And then you can say, I can in real time. This is not just, after the fact we do a process analysis. You actually are doing this in real time kind of information, which is even cooler. And you can then actually store this, so you can go back in time without re-executing everything, but you go through the history. But the idea of this is you really understand every single element of the code and the memory itself. So this is interesting because a lot of people struggle with the memory profiling. So the performance is what the layman, or does it fit in my time requirements? But actually, the memory is where most developers, I think, get hooked up on. So the memory issues are super, super difficult to find.
But at least tools that I have used have been horrible. That's why this whole journey of me is just, hey, let's solve problems I am having, and then, let's also help other developers out. And that started from learning how application functions, because documentation is most of the time not good.
Yeah.
And because who like to write documentation, you most of the times do not have a colleague that can explain it to you or has time, or is always not available. We all experience that probably. Let's make a system that doesn't require us to do anything, that can explain how a function works. Let's just make it store this data so I can play it back. So when, for example, a customer calls, it doesn't work. I just make a snapshot in there. I run CodeGlass on their machine. And then I store that, take it to my development machine, and I could just replay it without asking the customer anything or making a database copy. So
Yeah.
what our job is, if we can reproduce an issue, it's easy to fix.
Yeah.
But getting to the reproducible state is really hard. You can do it instantly. You just put your code next to it, and it went through this statement. It failed because the previous functions it called returned early, didn't prepare the data, and now it fails. Or even racing conditions, because we trace every thread at the same time. You can overlay it and see if threads cross each other and see a racing condition that way. Hey, solved. Okay, now performance. Let's make that easy. And then the next step was, memory. Also takes a lot of time. Let's solve that. And all in the name of, hey, let's make sure we can write more code every day instead of troubleshooting and doing all that kind of stuff.
I see. So maybe just to double click a little bit on the memory. Tell me more about this memory. So when you're doing memory profiling, typically what people do, there are many approaches, but a common approach is people will take a snapshot of the different memory and then they report out on it, and they have this hope that this memory is created and nothing is kicked in without them knowing about it, right? So that's a very common approach, which is, okay, on a fixed time step, I can say what is the exact memory and who's allocated it. But it feels that sometimes that is a suboptimal approach. But you seem to be doing something even cooler here, that you know exactly when memory is allocated by which process, by which thread, by which function almost. Is that true?
Exactly. Not almost. We do know that, and we know even where in your function you allocated that memory. So if you allocate at multiple points in your function a specific type of memory, we can deduce which of the, for example, 3 different paths to allocate a bit of memory. We can see which of the 3 you allocated.
Wow.
And then we can say, the other ones are fine, but the third one, that's where you allocate most of your memory. There's the 99% of your memory going. And, it's not being deallocated. We even can force a garbage collection from CodeGlass to, hey, if it is a managed language, just force garbage collection, please.
Oh, you
Check
could
if
actually
it's
force
been-
that? You can enforce it? So you can actually make it very deterministic of when your garbage collector kicks in.
It's not being deallocated. Yeah, it can be because garbage collection hasn't run or hasn't collected that generation of data. It's still not deallocated. Okay, it's probably a memory leak. We can see when garbage collection is run and which memory it deallocated and how much time that took.
Yeah.
Instead of reusing memory, you allocate it every time.
Yeah.
And we can see that. We can even now see. So you have, for example, in string builders,
Yeah.
are more efficient at allocating strings. We can now see, we can actually give suggestions. Hey, this function, you can improve it when using a string builder or array pool, or when, this much time, you can save this much time if you reuse this memory, instead of allocating every time and then let the garbage collector handle it, clean it up for you.
There has to be some gotcha around here. So Taran, tell me, what are the gotchas? What are the things that I'm not thinking about that deep down? And okay, there's some cases where this just does not work, or there has to be something like that. Otherwise, the whole world would be using this.
The only gotcha is that our UI is currently limited to Windows. That's something I'm bummed out about, because this all started with the assumption this doesn't work. So I didn't spend time in writing something like a web UI that would work on any system, because I wasn't really proficient in web.
Yeah.
So I wrote something that I was proficient in, and then it started to work. And now the UI only works on Windows, but you can collect your data on Mac and Linux and even IBM machines, specific ones. But you still need to either save the data and bring it to Windows, or make that remote connection to connect to my Linux machine to see the data. And you can run a virtual machine do it like that. It already works on ASL, for example, but that's something I want to do different. Make a web UI from the
Yeah.
start. We are working on it currently, but yeah, that's a shame.
Yeah.
But there is no other gotcha. If we have implemented the language, it just works. It's because we only have to figure out the translation layer, and for every programming language, that's different.
Yeah.
And after we've done that, it just works.
So, Tyrone, you mentioned that it sounds too good to be true, and sometimes it's hard for people to believe you. So, what do you tell people when they say, no, Tyrone, this is just not possible? How do you convince people that it is possible?
The first misconception that people have is telling us, yeah, but the data isn't in there anymore. And then because it's compiled, you don't have access to the function names anymore, or etc. And then I tell them the following: hey, if that application crashes, you still get the stack trace, right? Or in the event logger or in your own logger, you still know which function it was. Oh yeah, yeah, and they see it then, and then yeah, that's just part of the game we play, is mapping that back really quickly, really smartly, in how, hey, if the language can figure out which function name it is, then we can too. It's really hard, and sometimes you have to dig to a specification of a language over 800 pages to how to access that information. Then the second part is most of the time fun. Yeah, but that's this. You can't do this quickly enough, because that's why we sample. But that's why we sample memory and performance. And then I tell them, if you take every normal component, so software development, if you really look abstractly up to it from top view, we take existing components together and tie them together, and we have a new unique application.
Right.
How we communicate, how we build UI stuff. It's all, most of the time, it's components that already exist and we tie them together. And the first version I made for my thesis used these default components. And then I can say, yeah, then it wouldn't work. It starts to work when you really rewrite all the components. In the first version, we use SignalR. That's a common package for how you communicate between multiple processes.
Mm-hmm.
And then we could do 100,000 operations per second, and my CPU would be running at 100%. Then I thought, okay, this is a problem I need to solve, because, well, it sounds a lot in the grand scheme of a computer. It's not that much.
Yeah.
So how I'm going to tackle that? So I used the custom TCP stack. And then I ran into, okay, but JSON, it's not fast enough. It's too big. It's too much memory. I'm hitting the 1 gigabit per second mark on my network card. I have to solve that. So let's look into custom serialization. So we wrote, based on message pack, our own serialization format. And doing these kind of things, now we hit 10 million, and my CPU or my network card is not even my bottleneck anymore.
Ah.
And every step of the way. So it's a lot of data. So in first we used GUIDs as a unique identifier, because it would be nice. It would also be if we could. So for microservice architecture, you would want to look into multiple processes at the same time,
Mm-hmm.
and it would be a nice way to make your messages unique and traceable to the process, etc. Then we quickly found out that GUIDs are very big, between 16 and 32 bytes. It depends on how you serialize it and the platforms. It's a bit of a mess there. But if we wanted to cross-platform, you had to allocate 32 bytes for it, because
Yeah.
that's just how GUIDs worked on other argument platforms. Okay, let's get rid of that. Let's figure out still a way to make it unique, but only use 8 bytes. That's hard.
Yeah.
But then you have 8 bytes. That is a lot less. And then you don't have to serialize that. You don't have to store that. You don't have to deserialize that. And optimizing it that way, it makes it possible to reach that 10 millions per second mark. And we know we can even go faster. You really start to look at every byte you allocate. One byte more in that 10 millions operations per second would result in 570 megabytes per minute of
Wow.
extra data you have to serialize, send over the network if needed.
Yeah.
Because if you don't run it locally, you want to go over the network. Then deserialize it, store it, process it. You really look into even getting rid of 1 byte.
Yeah.
You make custom messages for everything just to remove 1 byte. And it's crazy. You get into stuff that you don't normally have to think about.
Yeah.
You just take for granted. Like, we can't use any kind of string in that 10 million operations because strings are dynamically sized. You can't assume the size, so we can't
Use
just,
strings.
yeah. So that made, okay, every function. So we didn't have to know what's function name. Okay, let's do a register of that function first, and let's make an idea out of that, and only with use those IDs in every kind of conversation.
Oh,
And
I see.
you work with a gigabit of data at least per second. You also have to work around your client with that, because normal tools all are recording. You stop them, they analyze, they process. It takes a few minutes, and then you can look into it.
Yeah. Yeah.
But we want to real time. We wanted to see. I want to press a button. I want to see what's going on with the application. So the client had to be made really smart about what it was seeing, what it was not needing, and making a system around that. So we made our own framework to make this easy for ourselves to extend our client. Because, so for example, the visualization of what the application is doing is not being done on the client.
Yeah.
So we have a background service that runs on your machine that collects all this data. That's that platform
Mm-hmm.
that we just tie all the languages to. And then the client is more lightweight, just, hey, I want to show the user some stuff.
I
And
understand.
it's actually queries on, so on the hub does that rendering, because that is rendering 10 million operations per second. So if I have to ship those all to the client,
Yeah.
my bottleneck would not be 10 million. No, it's 10 million. And then I have to send it to the client. So it's then how fast the client can do that, how fast my application can run. So we made rendering on the hub side and just create a viewport
Oh,
from the client. Hey, what's now visible to me? And then not what it already knew. And the server, or the hub, we call it,
mm,
knows what the client knows and only sends the changes. And doing all those crazy stuff you have to do to make this work. So every column, every value is independently asked to the hub, and asked only once. So if you have a value that's displayed 2 times, it's only asked once, and just,
yeah.
yeah.
So, okay, so let me see if I get this straight. So you're saying that historically, when you start new software development, people try to stand on the shoulders of giants, but you quickly realized that actually the only way to get to such a high performant way of doing it, you can't stand on the shoulders of giants, but you slowly but surely demystifying and or optimizing those giants' work to something of your own that enables complete new workflows. So it's a bit
Yeah.
like in the Python ecosystem, that Python generally slow, but people use Rust or C++ to accelerate things with, for example, Rough or UV. This changes the way people work. If you can get like a 10x speed up just by re-implementing things that people took for granted and people build on top of that. But if you say, let's rebuild this from scratch, you do get these 10x speed ups. This empowers new workflows. But in order to do that, you actually had to go over many hoops that is not for the light-hearted. So talking of custom TC stacks, talking about ordering, bytes, mapping. And when you think of bytes, 8 or 7 bytes, that's very different from you assuming, oh, there's a string and I just copy a string from left to. So, wow. So I guess this has taken years of development time to get to this place.
Yeah, it took 4 years, and now we are at year 6. But 4 years before, it really was at a point that we started to see results. And many times I rage quitted it and thought, oh, I'm done. And to just pick it up the next day. But I really want to solve this. For 4 years, I kept on working on the assumption it's not going to work. I'm just going to post why this doesn't work. I have the research on why this doesn't work, so no one else is going to need to try this like I have.
Yeah.
And that also made that on that side far too long, because I could release it a year earlier if I just questioned myself. I kept on
Mm,
searching, why wouldn't this work? Okay, it works for me, so what am I doing wrong?
yeah.
And etc. And yeah, that's a bit crazy.
Very cool. Okay, so what else have you got coming downstream? So you mentioned that you went through performance, then you hit memory. So what else is on your to-do list other than making the user interface cross-platform?
So we are working, like I said, on multiple languages. We're currently working hard on making it work for the Julia community.
Mm,
Other features, the biggest one we are working now with a few partners is an embedded version of CodeGlass
mm,
that you can ship with your production application. That just gives, for example, the user a button to report an issue and then instantly made that snapshot, the dump of data
yeah,
of the last 10 minutes, for example, or whatever you configure, and then just automatically send that to the developers to solve an issue. So
nice.
removing that whole need of asking what the customer did, or first line support.
Yeah, that's a great
Um,
sense.
yeah,
Create a
removing that need.
reproducible
Oh,
example.
yeah.
Yeah, yeah.
And then we want, so that's the first step, is making that snapshots work. And then a lot of features like also inspecting the values of memory,
Uh,
so that you can also see the arguments of your function, but also local variables that we show your local screen. If you are debugging and you are at a breakpoint, all the memory that you can access. We actually already do that in a few places. So like your exception message, CodeGlass catches all the exceptions that occurs, even if it's background or unhandled,
yeah, yeah.
and show the exception message. That's
Ah,
just reading memory from the application, and we can do that on a large scale. It's just an issue with privacy data,
yeah.
because there's an ethical question here, because CodeGlass can run without editing the code. You can run it on any kind of machine. You can put it in the background of public PCs and such. And
All of a sudden, yeah,
yeah, so that's something we are working out, how to solve that issue, ethical question.
yeah.
The worked out path for this is in closed languages, so that you ship compiled. You, as a developer, would specify in the application itself what is allowed, what CodeGlass is allowed to do, for example, and that way you can hide specific memory,
Oh, I
like a
see.
username and password or privacy sensitive data. But for more scripting like languages or
It's
source
harder.
based languages, it's anyone can overrule then those settings.
Yeah.
But yeah, it's, like I said, it's an ethical question we are still working out.
Fair enough.
Yeah.
Okay, so you say that the premise depends a bit of how or which languages you understand. So you say you've got prototypes in a couple of languages. Which are the most interesting languages that you're going after next, and why?
Yeah, like I already said, I really want to help developers out so we can do what we love, and that's write code. And we stumbled upon languages that are more niche based or still small, that even the normal profilers they don't have.
Hmm.
Like for example, now Julia, it's a really cool language. It's been a long time that someone showed me code that I couldn't directly understand, because Julia focused for the most part on physicists and mathematicians. So formulas, they write formulas, and I say, wait, is that correct code? And that's crazy, and it's really fun, because I don't get days quickly anymore, because we work on in the, for example, code base and the DVM, and we work through books of specifications. So that was really fun and something new. And but we also learned that there is not a lot of tools out there. So for example, they have only a sampling profiling, which requires you to change some code, and makes it able that they don't see everything. That
Hmm.
they also go in the wrong direction when searching for optimizations. So we really want to help them out, the Julia community, and started working on a prototype with a partner that we are currently developing to, yeah, also help developers in niche languages. We even are working on a COBOL version.
Oh,
So
wow.
COBOL, they still run it at banks, and people thought it was dying language. And now you see that banks are returning to it because the 10 years that they already spent in hopefully migrating to something different didn't work out. So you see a rise in tooling from there. So I thought, oh, let's also try it. And we have a working prototype
Yeah.
that we also now can help those where some people are really not alive anymore that wrote those applications that are still highly dependent on. And that is such like both are different, but is a different kind of market. It's not the mainstream developers, but you can do so much good there if you also give them tools like this. And we really like to do that more. And so after we finish Julia, go to the next more kind of niche language to help out those communities.
Yeah, so it turns out that when you create a new language where the community is a little bit smaller, the developer tools are sometimes an afterthought, right? So there's the core language, and then you realize you get a community going, and then you say for the community to accelerate, you need to empower the developers or the core members with the additional tools to make them more effective. But that's an afterfact, and you're stepping in at that turning point to say that if they have a lack of development tools, you can step in, and it's maybe easier to convince the Julia community that this is a good way of profiling, doing memory analysis, versus going into a well-established .NET to say there's a better way of doing it than what Microsoft provides, because the Microsoft says if Microsoft doesn't do it, then it cannot be possible. So you're going after the battle of, okay, the niche areas where you can prove your technology, and then if you get enough of them, then it becomes a much stronger case for you to go back to the bigger, more adopted languages. Is that a bit of the philosophy you're going for?
Yeah, exactly.
Yeah.
Also that, and you can do the most good in those languages because for .NET there are profilers, there are memory profilers. They are, in my
Yeah.
opinion, not as good and not as they are still clunky, but you at least have something. In the other
Mm,
languages, you don't, and so yeah, you make
nice.
the largest difference.
So that's also cool.
Yeah.
But one thing that I'm also curious about is your journey as an entrepreneur. So you started 11-year-old, like, okay, how do games work? How do I dissect my games? And then you just kept going down that rabbit hole, studied computer science, dove into .NET. You understood that, okay, there's a way of, you don't get new code. You all tend to analyze other people's code. And that was a painful process. So you decided to make it your mission to create tools to make it easier to understand other people's code. That then turned into a company that then went from seeing code, function calls, stack traces, performance, memory, and you keep going down this. So tell me more about this entrepreneur journey that you also said that it's not just having the right solution and putting it out there. Tell me more of some of these war stories of the young Tyrone who created a company to the successful entrepreneur you are today.
It's not even a young Tyrone, it's just less than 2 years ago. But yeah, so like I told before, it started to work and I wasn't really believing in myself, but then we saw results from outsiders. And at that point, I can keep it for myself, but then I'm not helping anyone. This makes me so much happier as a developer. Let's just give it in the hands of as many developers I can get access to. And then at that point, I also Googled again at this problem, and people kept on saying this isn't possible. So if I wasn't going to put it out there, no one will,
Yeah.
or no one still will, and that would just be a shame. So then I thought, okay, then I have to do it myself. I was lucky that, so I told you I did it as my thesis. And still, even after 4 years, my professors were very interesting if it was actually going to make it, because they were also convinced it wouldn't be possible. Because, well, else they would teach developers differently how to solve the things instead of just go into the code and solve it. That's part of your job. No, they would also teach it differently. So they were very enthusiastic and even gave me over the summer free courses in entrepreneurship. When I outgrew my university, I went to, they used their connection to an even bigger university in the Netherlands, one of the top four universities, the University of Twente.
Yeah.
And they have a larger program, larger reach. And so in the span of 4 months, 5 months, I went from a developer that spent his days a week on solving this issue to going everywhere and talking about money like it's nothing. It's really weird. Without much effort, we got a grant from that university for 100,000 euros to really start up our company. We went to events, to London, to Slush in Helsinki, to CES in Las Vegas. So our first company retreat was CES in Las Vegas. Yeah, that's just, we also got, the Netherlands is pretty great in this, the RVO, I don't know how it translates in English. Yeah, the literal translation would be the Netherlands Entrepreneurship Agency.
Yeah.
That motivates entrepreneurs, also innovation, and they bring startups from their portfolio to all these events, and you get invited to them. With them, we went to these events and not CES, and we actually got 10 tickets for CES, and then we thought, let's just bring everyone.
Yeah.
Let's figure out cheap plane tickets and etc. for everyone, and let's also have some fun. Company retreat is going to Las Vegas, and oh, what a crazy town it is. Yeah, and we are also going to Slush again to finance for next finance round. And yeah, but still it really feels not natural yet. I'm a software developer but to my very core. So even standing in public, standing on podiums, it was really a natural feeling. I still feel a little bit of like an imposter every time I'm doing this.
Yes.
Also doing this podcast is something I wouldn't thought I would be doing like less than 3 years ago. So
I think it's an inspiring story, right? You at a young age seem to have discovered your passion and you kept hitting and going deeper on that. And I think it's nice to see that environment around you empowered to create your company. And I think what you're doing sounds super interesting. If people want to reach out to you and try this out, what's the right way to reach out to you and learn more?
So we have a Discord that you can access to our website, CodeGlass.io. And then by contact, you can join a Discord. And if you just want to try it out, just send me a message. I will give you a license for free. At least if you provide some feedback, it will be really valuable, because what you said, Garrett, it's almost seemed too good to be true. And that's a lot of the problem we've been having, is nobody believing us that this is possible now. And just get the door slammed to our faces with reactions like, we actually had this over 2 times. If this would be possible, Microsoft would already have it. And then they close the door with literally, I'm having it standing in hand with it. And so getting in touch with developers is really hard, and getting them to try it out, because yeah, it sounds too good to be true. It sounds like selling snake oil.
Yeah.
And we all get so much spam through any kind of social media, LinkedIn and etc. I fully understand why people are ignoring me, because I also get 10 of these messages a day that are worth nothing. Just send me a message. I will give you access. I will explain to you how you can use it, and please provide some feedback. Then we can continue developing it, because that's most of why they are still in development, is because we do not have enough of a feedback cycle to really put it out there.
That's it for today's episode. I hope you enjoyed the conversation and found it valuable. If you did, please consider sharing this episode with your friends and family, or anyone who might benefit from it. Also, I'd love to hear your thoughts, so take a moment to leave a review and let me know what you think. And if you haven't already, don't forget to give us a rating. It really helps us reach more people and bring you even more amazing content. Thanks for tuning in, and I'll catch you on the next episode.